Deb again here with another question from your Hayes and Harris Math SL textbook. This is chapter 6C.3, question 2, parts A and C. We're given a quadratic expression and we're asked to show that it's greater than 0 for all values of x. So the first thing that I'll note is that the constant term in front of x squared is positive. So that's A. So for part A, A is equal to 1. At the same time, C is equal to -3. Sorry, B is equal to -3, and C is equal to 6. But I'm really concerned with the fact that A is equal to +1. Because A is positive, that means that we are concave up. Because A is positive, this is a smiley face function, not a frowny face function. So if it's going to be positive for all x, we just have to show that it will have no x-intercepts, or at most one x-intercept. So if I'm concave up, like this, then as long as it's above the x-axis all the time, then it will always be positive. It could maybe just touch the x-axis, have a double root, and that could, and then it won't be greater than 0 anymore. It'll be equal to 0. Or it could have two x-intercepts, and then it's definitely not always greater than 0. It'll have a region in which the value of the function is negative. So what I want to show is that there are no real roots to this quadratic, and I'll do that using the discriminant. The discriminant is equal to b squared minus 4ac. So that'll be -3 squared minus 4ac. That's 9 take 24, which means that the discriminant is going to be negative. Therefore, there are no real roots. So because the quadratic is going to be concave up, and because it has no real roots, then x squared take 3x plus 6 is greater than 0 for all x. Part C asks a very similar question. It gives me a different quadratic, and it says show that it's positive definite. Now that's just another way of saying that it's going to be greater than 0 for all x. Positive definite means that the function is always positive. So I'll solve it the same way. In this case, A is 2, B is -4, and C is 7. And once again, because A is greater than 0, we're going to be concave up. So in order to show that this is positive definite, I just need to show that this quadratic will have no solution, so that it's always in quadrants 1 and 2. And I'll do that again using the discriminant. That's -4 squared take 4 times A times C. That'll be 16 take 56. And so once again, the discriminant is less than 0. Therefore, no real roots. Therefore, 2x squared take 4x plus 7 is positive definite.